In a world driven by innovation, we stand at the forefront of technology, pushing the boundaries of what's possible. Introducing eConsulate, where innovation meets excellence. With a global presence and over 120 dedicated experts, we are not just a company. We are innovators in software development, artificial intelligence, and robotics. Our journey began 3 years ago, and since then, we've been on a mission to revolutionize industries and transform the way businesses operate. Under our umbrella, you'll find ventures like Saver AI, where cutting-edge robotics and AI are redefining possibilities. SCM Studio simplifies logistics with SCM Bridge, our shipment management platform. And Tasa Lanka provides tailored business process outsourcing solutions. We cater to over 10 diverse industries, delivering innovative software solutions, conducting advanced R&D in robotics and AI, offering top-tier tech resources to develop top-notch software products. But we don't stop there. We actively invest in scalable products such as fintech, health tech, disaster management, and AI, because we believe in nurturing talent and driving innovation forward. Join us at eConsulate, where innovation and excellence come together to shape the future.
The future doesn't belong to the faint-hearted. It belongs to the brave. It's all part of taking a chance and expanding man's horizons. It's all part of the process of exploration and discovery. We're still pioneers. We've only just begun.
The true sign of intelligence is not knowledge, but imagination. Good evening, everyone, and a very warm welcome to our online workshop on Unlocking Intelligence, Dive into AI, as a part of the workshop series of the prototype phase of CodeSprint 8. It's truly a pleasure to have each and every one of you join us today as we embark on this exciting journey into the fascinating world of artificial intelligence. I'm Abhini Tirthanesan, and I'll be the moderator for today's workshop. Now, I would like to introduce our esteemed speaker for today's session. Today, we have the privilege of hearing from Mr. Pamoda Dilranga, a senior machine learning engineer at Rootcode. He will be guiding us through the intricacies of building optimized machine learning models and applications. If you have any doubts or queries, feel free to post them in the Slido link provided in the chat box, which will be answered later on during the Q&A session. Now, without any further ado, let's give a very warm welcome to Mr. Dilranga. The virtual stage is yours, sir.
Thank you, Abhani. I hope you guys can hear me clearly. Hope you guys can hear me. Cool. Let me share my screen. Great. So guys, welcome Welcome to the AI workshop. So today, first of all, let me introduce myself a little bit. I am Pamoda Dilranga. I am a senior machine learning engineer working at Rootcode AI. So currently, I am mostly working on building machine learning models and deploying those kind of models and optimizing these models to be better and faster. And other than that, usually for my leisure time, I watch movies, play games, those kind of stuff. So yeah, let's get started. So the topic of today's workshop is building optimized machine learning models and applications. So when we look at this topic, there is one word really important, which is optimized. So what is the word optimized mean? So when I did a little Google research, this is what came to me. So optimize is making the best or most effective use of a situation or a resource. Now, I think all of you guys have deep learning, machine learning in your university. So you guys should know how to build machine learning and deep learning, right? But just building a model, as the book says, is not the best way to do it. You can optimize it more. You can optimize it more to become more accurate, or you can optimize it to become more faster. So today, in this session, we are going to look into how we can make these machine learning algorithms, deep learning algorithms, more optimized. So for that, I selected these 4 stages we met when we are doing a machine learning project or a deep learning project. First of all, as you guys know, we are preparing the data. We are getting a data set because in AI, in data science, data takes a big place, right? So in the first stage, we are preparing the data set. Then we are selecting a perfect model for our problem, and then we are training that model. And finally, we might deploy that model into a production instance. So today, with the time, I am going to talk what are the optimizations we can do, what are the things we can do to improve these stages that we met during our machine learning journey, building a machine learning application or a deep learning application. So cool. Let's get into the first stage. So first of all, before starting anything else, we are preparing our data. So as you guys have already done, I think you guys have good knowledge in AI and machine learning. When preparing data, normal things we do is we are handling missing values. If there are missing values, we are fill it with mean, or we fill it with some kind of a dummy values, something like that, or normalization, standardization, and encoding, things like one-hot encoding, label encoding, things like that. So these are the things we usually do for preparing data, right? But other than that, we have some other steps to do to make sure we are getting the best out of the data we have. We are building the best model we possibly can. So first of all, we need to figure out what we need for this model. When you get a data set, for example, let's say you guys are doing a machine learning or artificial intelligence course in your university, you guys might get a data set with like 100 columns or 50 columns, like a big data set, like a lot of features. So do you need all of these features for your model? Might be not. So first of all, we need to recognize, okay, what data points, what features within this data set will be really applicable for a model. For example, let's say this as an example. Now, let's say I am creating a model to predict the purchase patterns or recommend the purchases for the users. For that, I go to a supermarket, and supermarket gives me this kind of a data set. This data set have a product ID of some user, when some user buy a product, and what kind of a category these products belongs to, or when did this user bought this product. And also, let's say this is like an online store. They might have server logs saying, okay, what kind of a server request came in to fulfill this order? What kind of IP address this order came from? What kind of events? What kind of security events? What kind of payment events? All of these data might be inside that one data set. But do we really need all of this data? For example, the server logs, we don't need that, right? We are creating a pattern recognition. We are creating a model to recognize the purchasing patterns or recommend new products to the users. In this case, the server request, the IP address that those servers came from, and the events like security events, payment events might not be directly useful to us. So this is just a simple example. This can be changed depending on your use case. Now, let's say you got a data set, something really complex data set. How can you recognize which features to keep and which features to not to keep? So that's the question that we are going to answer next. How can you recognize unwanted feature in a data set? First, there's a method, doing it manually. First of all, we need to understand the problem we have and what kind of relevant features. So it's basically a mind game. And sometimes, let's say you become a CEO of a tech company. Now you are a CEO of a tech company, and this CEO of another agricultural company come to you and ask for an AI application that is based on agricultural data. Now you are a student of IT, right? You know everything about IT. You know a lot about IT, but you don't know much about agriculture. In this case, you need to get a consulting from domain expert or the stakeholder you came looking for you. So getting idea of the problem, and then you can look into the features what you have. Okay, do I need this feature? This is one of the manual ways to do it. You can just simply remove the features that seem to be, or that you are sure that not valuable to the model that you are building. Then we have feature importance techniques also. For example, we can do EDA, exploratory data analysis, or we have correlation analysis, or we have feature selection algorithms like recursion feature, elimination, lasso regulation. We can use these kind of algorithms and techniques, and they will give you a score saying what is the importance of the given feature within this data set for the target variable. And using that, you can remove these like negligible, like non-impactable variable features in your dataset. Why do we need to remove the features? So what happens if I just pushed everything with server loads, everything I'm pushing into the model, and then I'm just making it train itself? What happens then? So you push lot of data. That means it will take a lot of time to train. You will need more system resources. And model, sometimes it might be a bit hard. Why? There are complex patterns. It doesn't get idea about, okay, how does server logs connect to the purchase? It can't think about it, right? So it might just go with that wrong idea, and it might do some complex things to get the idea how these two come together. So that's why we shouldn't push everything we have, and we need to select exactly what we have, and then figure out what features we need, what features we don't need, and push the features we need only. That's the first thing. Then we can engineer what we can engineer data that we don't have. We also call this feature engineering. So let's look into feature engineering. How can we can do feature engineering? Now, if you guys remember the last example, we had product ID, product category, purchase date, those kind of things. Okay. Now, in here, there are only 3 columns, right? 3 information. This might not be sufficient enough for model to train on. Now what we can do? We can introduce new features into the dataset using this kind of information already available for us. Now, let's say I have the product ID. Using the product ID, I can just get on some database and I can figure out, okay, who is the manufacturer of this product? What is the country of origin of this product? And this might be really valuable for me. Why? Let's say we are using this data for create a product recommendation algorithm or machine learning algorithm. So some people might like one manufacturer rather than the other manufacturers. For example, let's say someone comes in and buy Anchor milk powder. That person might buy Anchor butter instead of some other company's butter because that person might like the manufacturer better. So if we can recommend that person the Anchor butter instead of some other kind of butter, then that would be a win. And some people really like to get things that are exported from other countries, from Australia, from America. They don't like the things that have grown in Sri Lanka. Some people are like that. So for those kind of people, I can select them with if I know what country of origin the product that they are buying is coming from. If I can see a pattern, they are buying only Sri Lankan products. Okay, I can see, okay, this person likes Sri Lankan products more. When I am recommending this person products, I have to push the Sri Lankan products in top of all the other products. That is one way to add more data into your data set with the data you already have. Now for this, we looked into data sets, we collect data, we did a lot of things. But we can take something like this also. For example, let's say we have purchase date of the purchase that have been made, right? So we can just, it's 2024, fourth month, 25th day. We can just pass this data into a simple library and we can figure out what day of the week it is. Okay, it is a Wednesday. What month of the year it is? It's April. This data will be valuable when we are predicting the user patterns, the product patterns. For example, some products might sell more on certain days rather than the other days of week. If I think about an example, let's say we are going for hiking, okay, trekking or hiking. No, when we go on a hike, we don't usually eat rice or anything. We eat something really instant, something we can make really quickly, right? So we might take multiple instant noodle packets like Maggi, Kothumi or something like that. And we will take them and quickly prepare them and quickly eat them. That's what happens in hiking, right? Now, let's say we are in a location that are really popular for hikers. Let's say we took these data from a supermarket in those kind of a location. So usually hikers doesn't go hiking in weekdays, right? They have jobs, they are doing their jobs. They are going hiking on weekends. So we might see spike of instant noodles buying on the Friday. Why? Because they are going to go hiking on weekends. So they might buy instant noodles more on Friday nights or Friday day. This is just one example. It might not be just like that. I am telling you to understand it better. And month of the purchase. This is really good when we are thinking about the patterns, the user buying patterns. So if you guys near Maharagama or I think other area, when it coming into April, you can't just cross Maharagama town or Kiribati town. Why? Lot of people from all around the island coming into those areas to buy clothes, buy apparels. So the month that the purchase is happening can be effect on the purchase pattern. If it is April, we might buy more clothes. If it is April, we might buy ingredients to cook cow, cookies, ask me those kind of things. So I have tell the model, okay, this can happen. This month can be a factor. This day can be a factor. But if I just input 2024, 425 as an integer or as something, we might not highlighting that to the model. So if we can feature engineer and we can show it clearly day of the week and month of the purchase, that might be help for us to build a better model rather than the model that we are building normally. And obviously we are going to encode this in the future. So Wednesday might be an integer, April might be an integer. So we can encode it using things like label encode. Now, that is the importance of feature engineering. Now, how can we do this feature engineering? That's the next question. Mainly, we can use mathematical methods. Things like we can use mean, median, mode for let's say we have a list. Instead of taking this list as a data point, we can fill it with the mean of the list, median of the list. Or we can simply create new features by performing mathematical operations such as addition, subtraction, or division. The next thing we can do this feature engineering for text processing. We can encode categorical variables using one-hot encoding, using label encoding, or we can tokenize these data, convert text into tokens, words, or phrases. Or we have more advanced methods such as TF-IDF. So let's say we have a text corpus. Since I talked about Aurudu in the earlier example, I take about this also. I have written paragraph why cow is so good. Why cow? I can eat lot of cow. So within this text, I might have mentioned cow in a different places, right? I might have mentioned it 5 times rather than other words. So obviously, cow have a big impact. Cow has big importance within this text rather than other words. So in IDF methods, it will bring this up. It will transform text data into numerical vectors based on word frequency and the importance of the word. So again, this can be really easy for a computer to for a artificial intelligence model to learn instead of just giving the text as a normal encoding. This is one kind of a feature engineering also. And then the next thing, as I said earlier, if you have domain knowledge, then you might know, okay, if we multiply these two numerics together, I get this ratio, which is a really important thing when we think about a AI model or a machine learning model. So if you have a domain specific knowledge, then you can convert that into new features also. Great. So that is preparing data. There are a lot of data preparing techniques. I am talking like a basic things that can help you to optimize your model rather than just building the model. Now, let's say we have perfect data set. We have pre-processed all the data. Now, we have to select the model. When selecting the model, we have to think about a lot of things. Okay, model selection based on lots of things. Sometimes we have these three choices when we go into selecting models. Are we going to use the traditional algorithms? Or are we going to use a machine learning algorithms? Or maybe you guys want to use the neural networks. But when to use these algorithms, when to go into neural networks, is it deep learning or machine learning, is need to be evaluated carefully. Now, let's say when to use each of these algorithms. Now, let's say you have a less complex problem. And when you look into the dataset, you can see clear patterns. For example, there is a X column called X in the dataset. If this X is higher than 100, then it is a class A. If this X is lower or equal to 100, then it is class B. So it's really easy, right? We have a clear pattern to recognize in the class. So we don't want to build a machine learning model or a neural network just to recognize the class. Why? Because we can do it really easily using a traditional algorithm, using if-else statements or while loops, those kind of things. Now, if you use traditional algorithm, it will use less computational resources. So it will be good for your pocket as well, because you don't have to spend much and you don't need much computational resources. And when we think about neural networks, we can't just explain what happens inside neural networks, right? Most of the neural networks, we can't do that. It's like a black box. You give some inputs, you get the output. How the neural network got that output is a question for us. But if you use an algorithm, then you can explain, okay, this happened because it got filtered on this if condition, it got filtered on this while loop, and it got into this section. Now, if it is, as I said earlier, really less complex and have clear data patterns, go into traditional algorithm. Don't go into ML and DL approaches. Now, when to go into machine learning algorithms? Now, let's say we have tasks that have moderate complexity, like finding patterns, making predictions, clustering, something like that. And let's say we don't have a really big data set, so it can be a bit smaller data set. So in this case, we can use machine learning algorithms. But the thing with machine learning algorithms, they need manual feature engineering. When we compare that with neural networks, for some extent, they can create feature engineering by themselves. But machine learning algorithms take less computational powers most of the time compared to the neural network. So if you can do that with machine learning algorithm, if you can see the patterns, you can get a really good accuracy. Do not go into a neural network. Why? It is waste of time and it is not the most optimized way also. And then we have neural networks. Use neural networks when you have highly complex and non-linear problems. It is really good at image recognition, natural language processing, sequence predictions, those kind of things. And in natural neural networks need big data sets in most of the time. There are times that it doesn't need big data sets also. But most of the time, comparing to ML approach, neural networks might need big data set. So if you have a big data set, neural network might be ideal. And most of the time, neural networks can automatically learn some of the features and do the feature engineering itself. But keep in mind, neural networks might take more computational power rather than traditional algorithms and the machine learning algorithms also. Good. Selecting a machine learning algorithm is actually a depends on the problem. If you have a classification task, you can use one of these logistic regression, support vector machines, those kind of things. If you have regression task, again, linear regression, ridge regression, those kind of things. Clustering KB means, DB scan, those kind of things. You can find a list of these kind of machine learning algorithms in the internet. It depends on the problem you have. Okay. Now, when we think about neural network, when we are building a neural network, we can do it in two ways. The first way is we can build a neural network from scratch. Everything from us, from the initial point to the ending point, we build it from ourselves. Or we can use already pre-trained neural network. I think most of you guys have used these kind of neural network, VGG19, BERT, ResNet, YOLO, GPT. We can use those kind of pre-trained neural networks also. And if we take a pre-trained neural network, we can freeze the layers that is already trained, which have the weights, and then we can add the needs of ours into the top of that and create our solution. So these pre-trained models are created by companies like Google, Microsoft, those kind of companies. They have trained this pre-trained model with millions of data, billions of data sometimes for a long amount of time. So when to select building from scratch and when to select pre-trained neural network models. Now, if you have a limited data, let's say you don't have much data on the use case that you are going to do, then building a neural network from pre-trained neural network is the best approach. Why? Because that neural network is already trained on millions of data. So if you have less data, that is the best approach you can go. But it should be a similar task. For example, let's say I have a pre-trained model that trained on cars, trees, houses, those kind of images. It might not be ideal to use that pre-trained model to recognize brain tumors. Why? It's never trained on brain tumors, and it's more of a segmentation problem, finding a brain tumor in an X-ray. So you can use a pre-trained neural network if you have a pre-trained model that were trained on a task similar to yours. And the next thing is time and resource. If you are using pre-trained models instead of building a neural network from scratch, you can save a lot of time as well as a lot of computational resources. So it will be really, really optimized also. Great. Now that's pre-trained neural networks. Now let's see when should we create neural networks from scratch? So if we have a domain specific task that's highly specialized for something, for example, the task I mentioned earlier, like creating a neural network to find the brain tumors. These highly specialized, right? Doctors know how to do it, and it is really, really domain experts know how to do it. It's domain specific. So you can't just pull a pre-trained model that were trained on, as I said earlier, from horse images, car images, those things, and push it to this brain tumor segmentation. You can't simply do it. So if you have a really domain-specific task, start building from the scratch. And you have a lot of labeled data, then building from scratch might not be a big problem. Why? You have data. It is already labeled. And you can simply just create an architecture and do it. And the next two points show you can take the control over your architecture. So let's say I am using pre-trained model, then I don't have 100% control on my architecture all the time. The pre-trained model have some layers that are freezed. They are just like that. I can't change them or their weights most of the time. But if I am building something from scratch, then the architecture will be on the type that I need it. I can change it, I can change the weights, I can change different parameters, everything. So let's say you are doing a research. If you're doing a research, if you start building the architecture from the scratch, then that might help you to get new ideas. While building, you know about the architecture, you see how each layer filter data. Then if you're doing a research, that might be really good for you because you can change everything. Everything is under your control. So this is when we need to create neural network from scratch instead of using pre-trained models. Cool. So that's how we should select a model, either machine learning, deep learning, or traditional algorithm, or if you are going into deep learning, are we creating it from scratch or are we doing it using a pre-trained model? Okay. And also there are a lot of neural networks. You can use CNN for image processing. You can use transformers for NLP, and again, another set of tasks also. So we can just look into that. Now, let's move into model training phase. Now we got the data, pre-processed the data in the optimized phase, and we optimally selected what model to use. Now we are going to train the model. Now, one of the things we do in training, okay, now I got all the idea, I need this model, I have this data. Now let's pull up something and start training. First of all, we have to select a proper framework. Most of the students, most of the people doesn't give enough attention to this. So they are using, if they are using TensorFlow, they are familiar with TensorFlow, they will keep on using TensorFlow. Or if it is PyTorch, they will keep on using PyTorch. But before you moving into the model building, model training phase, think what proper framework to use, what deep learning framework to use. So obviously your development experience coming first here. If you are really good at syntax or you know how TensorFlow works, then coding in TensorFlow and creating this project in TensorFlow will save you a lot of time rather than doing it with PyTorch. But there are other separate factors also. For example, frameworks ecosystem. So there are a lot of pre-trained models, libraries, and tools that comes with these kind of frameworks. So let's say you are using TensorFlow for something, and if you are doing some mechanism manually, there might be a tool or a library in PyTorch that you can use to do it automatically. So when you are going into a problem to solve a problem and build a model, think about the ecosystem of the framework, which will be really helpful to you also. And then the next thing is community and support. So all of these, this is just two really popular ones, PyTorch and TensorFlow. All of these have really good community support. But if you are going for something else, something really novel, something really new, then you might not get big community support, and that might make your process slow, because when you find a trouble, you can just troubleshoot it, you can just fix the bug. You have to find it yourself, you have to fix it yourself, rather than taking help from documentations, forums, and other community support forums. And last, think about the compatibility. So when we come into a production stage, rather than building just a model, AI model, and deploying it, when we come into production stage, we might not build just one component, just one AI model won't be there. There might be multiple AI models here and there. There might be other complex models and other kind of things. So we have to check compatibility with these other AI models, other modules, with the framework that we are going to see. Okay. Cool. So that's why we need to select the best framework we have. Cool. Next, we have to think about selecting proper hardware infrastructure. Now, I think you guys might have know about this, or you guys might not. But if you guys playing games, or you guys have been in deep learning community for some time, I'm sure you guys have heard the word CUDA. So let's see what CUDA does. Now, you know, we have two processing units in most of our computers. We have central processing unit, which is called CPU, and we have the GPU, also known as in Sri Lanka, VGA card or VGA. Now, when we train an AI model, especially neural net, there are a lot of complex mathematical things happening here and there. It can happen on your CPU, it can happen on your GPU. But let's say you don't have a really big CPU. You have a mediocre, like a okay CPU. Now, if you start training a model on this CPU, it might take a lot of time. But if you pass this model, the complex mathematical part, into your GPU, and if you have a really good graphic card, a GPU, then you can do it really fast. Why? GPUs are built for these kind of things. So CUDA is something that created for this purpose. It can take this complex mathematical part out of the CPU and give it to the GPU. So CUDA is created by NVIDIA. So NVIDIA is again a business company. So CUDA technology won't work in any other provider's GPU. It will only work in NVIDIA GPUs. But other providers have some technologies. For example, AMD have this ROMZ. I don't know how good those are, the most popular, most effective way to do this now is CUDA. So let's say now you have the model, now you have everything, now you are in model training stage, right? Now you are thinking, okay, what kind of hardware should I use for training? Now let's say, okay, for some reason, I don't know why, you thought to take another laptop just to train your model. Now, if you went to the shop and if you pick out a really high-end AMD GPU and a really high-end computer, that might not support CUDA. And in that case, you might not be able to effectively train your model. So it might take some time. So I'm not telling just buy NVIDIA, but doing so, check out their framework that they have for interacting, like sharing the load between CPU and GPU, especially in this deep learning task, and then buy the solution that we are going to buy. Now, let's say you don't have that crazy idea. You don't need that crazy idea of buying a new laptop just to train models. So what can we do? The next possible and the cheapest option is going into Google Colab or Kaggle. So I think most of you guys have already used Google Colab. Google Colab is something offered by Google that help you to train your models without any pay. But there are some restrictions. But it have really good system resources. For example, as far as I remember, Google Colab have 16 gigs of RAM and it have NVIDIA Tesla K80 as far as I know. So these are really good graphic cards and really good GPUs. And you can connect your drive to your Colab, so that have around 15 GB of storage also. But it has some downsides. For example, you can run maximum 12 or 16 hours constantly, and it will expire after that time. So your training will stop. But still, for most of our models, Colab will be enough. And there are like paid tiers of Colab also, which give you a lot of time, which give you really good GPUs and really good RAM modes. So if you are not using that kind of things, you can go to something like Colab and you can speed up, or you can optimize the process of training your model. Or let's say you need far more resources than that. Then you can turn into Azure or AWS, those kind of a cloud service provider. Google have cloud service called GCP or Azure or AWS. Then you can simply buy an instance which have a good GPU with good RAM or good SSD drive, really fast SSD drives that are optimized to train neural network models. Okay. Now, this might cost you a little bit. Why? Basically, they are a bit pricier, especially you are going for really, really good GPUs. So keep that in mind also. And if you don't need this much of higher compute power, don't go into that. If you have a NVIDIA RTX or GTX in your home laptop, and if your model can train on that home laptop within several hours, then go for that instead of buying high-end AWS instance. Great. Then let's say even you bought AWS instance, one instance, doing your training. For some reason, it is also really low. You have a really, really big data set with really complex model. In that case, you can consider parallelism and distribute training. So we might have one GPU or TPU in our instance. So these kind of cloud computing providers are offering distributed training that have multiple GPUs, sharing the data sharing within these GPUs, which will speed up the process that you are training your model. Then this is one of the now this is how we select the proper hardware infrastructure. Now let's say we got that sorted out also. Now we have to make sure the model that we are training is training in a proper way. It's not going to overfit or something else. Best way to do that is using early stopping. So what is early stopping? Before that, I think since you guys have already done AI related courses in your university, you are familiar with overfitting. So we have two types of data set. A data set we use for training and data set we use for validating. Now let's say this training data set. Now let's say we are creating a artificial intelligence model to recognize dogs and cats. Now let's say in the training data set, we have cat pictures as well as dog pictures. But most of these dog pictures are from, let's say, husky dogs, the breed of husky. They are white, they are black, they look like wolves, like that. And Your validation dataset might contain some other dog breeds also. At some point, your AI model will look into 100 husky images and it will think, okay, if it is a dog, it should be like this. It should be white. It should have this kind of characteristic. So if you show some other kind of breed to your model, it might say, okay, this is not a dog. This should be a cat. Why? It's not look does not look like a husky. So that is overfitting, as I explained. So in overfitting, your model is really generalizing on your training data, not your validation data. So this is a graph that shows how that happens. So at this point, it is at optimum. It have really good training error. That means it have less training error as well as validation error. But from this point onwards, I hope you guys can see my mouse. Yeah. But from this point onwards, the validation error keeps increasing and the training error keeps decreasing. Now, this is the point where overfitting started happening. Now, let's say you done everything, you prepared your data, pre-processed your data, did everything, and you put your complex AI model to train overnight. You even bought AWS instance. Now you start training on today at 9, and then you went to sleep. And tomorrow around 10 a.m. you had lecture, so you couldn't see. And you come around at 2 p.m. tomorrow and check your model training. Now what happens? You see really big validation error and really low training error, which means your model started overfitting, which means the model is not going to help you at all. Now, this is a big resource wastage as well as big time wastage. So that's why we have early stopping. So when talking about early stopping, we have these kind of parameters that we can set. First of all, we have the monitor parameter. We can say to our deep learning framework, okay, monitor this exact metric. For example, it can be a validation. We are telling to our deep learning framework, okay, keep monitoring this green line, this validation error. Then there is another parameter called patience. It's saying how many epochs, like to wait for improvement. For example, here you guys are familiar with epochs as far as I know. So here until this point, it's improved, right? Validation error got reduced. That means it improved. After this epoch, it start getting worse slowly. So patience means how many epochs you have to wait until you make the decision. Okay, now it's getting worse. I have to stop it. And other things we have mean delta, that means minimum improvement that count as progress. For example, at least 0.0001 decrease should have in validation error if we are counting it as progress. And then we have mode. Should this become minimized? If it is a accuracy, it should maximize over the time. If it is a loss, it should minimize over the time. And then we have restored for best weights. This is the part that really helps us. For example, let's say now early stopping is monitoring this green line, the validation error. After, let's say, 10 epochs, it recognizes, okay, this is not getting any better. Model has started to overfit. So I have to stop it. So if we turn restore best weights parameter to true, then it will remember the weights of this moment exactly. That means once the early stopping stopped the process, since the model is getting overfit, you can come back to this exact point which have the best possible weights for that model. So using this, we can actually prevent model from getting overfitting over the time without even us noticing. So this is a really good way to optimize your training as well as saving your resources. Great. So that's about training the model. Now, our deep learning things doesn't stop after our training, right? Then the next thing we have to do is deploying the model. As far as I know, in the CODESPRINT, you guys are creating prototypes for these big ideas. Then you have to successfully deploy these ideas also. Because product is not just an AI model. It's something much more bigger than that. So when thinking about deployment, we have to talk about cloud. As far as I know, you guys have upcoming cloud workshop also, so you will learn a lot in that also. When you are deploying, one thing some people do when it comes to AI models, they are just getting an instance from AWS or Azure, and they are just installing needed packages and just spin up the model on that instance and start using that. You shouldn't do that. Every time you can, start containerizing your AI models or your neural network models. So if you containerize the model, it is easy to deploy, it is easy to scale, and it is easy to manage. So you can use things like Docker or things like Kubernetes to help you with this. And when you are doing it, remember to minimize the dependencies. For example, let's say you have a NLP model that you have used XLNet, BERT, and Lambert just to test the model. And you found best performance on BERT. Now, if you put all the dependencies that needed for Lambert and XLNet into your Docker image, you are not minimizing the dependencies. We don't need those dependencies in. So just keep the dependencies you need and use lightweight base images also. For example, if you can do something with Python based image, don't go into a Ubuntu or a Linux based image. Why? They contain heavy weights, they contain a lot of resources, but we might not need them for our exact purpose. So when you are containerizing, think about that also. Then the next thing you can do in model deployment, always use auto scaling and load balancing. Now, what is auto scaling? Let's say you have created your project for CODESPRINT 8 and you successfully won it, and then you successfully deploy it into a service. Now, let's say it's a week before Aurudu, the day before Aurudu, you got a small AWS instance, because you are getting around 100 users per day. You got small instance and you deployed your model in that instance using Docker and everything. And then you just close your laptop and went into 4-day vacation because of the Aurudu. Now what can happen? On the first day of Aurudu, there might be 10,000 users coming into your product, and your server, the small server that meant to handle 100 users per day, might crash because it can't handle the user load that coming in. In that case, auto scaling is the best thing to do. So here in this blue image, you can see horizontal auto scaling. So let's say you have 3 instances initially you got. As soon as the users getting increased, without giving more weights into these instances and crashing these instances, it will spin up new instances and push new users into them. That is auto scaling. And then load balancing. It doesn't matter we have 3, 4 or more instances. If we push all the traffic coming from one coming into one instance, so we have to divide it into instances that are free and take the maximum output out of it. So this is something you can do in model deployment stage to make sure that your model is running as optimum as possible, as well as there is no downtime or crashing in the service. So yes, so that's all I had to talk about today. I think you can have gained some knowledge with this. So this is how you optimally build a AI project with these kind of things. I think you can build really good optimum model that might perform really well as really fast. So yeah, thank you for listening. If you guys have any questions, you can ask from the forum, as your friend said in the starting of the meeting, or you can just send me on LinkedIn. I'll reply to them as soon as possible. Yeah, thank you.
Thank you, sir, for your valuable insights. Now we move on to the interactive segment of our workshop, the Q&A session. This is your chance to engage directly with our esteemed speaker. Don't hesitate to ask any questions that you may have using the Slido link provided in the chat. Let's make this session as informative and engaging as possible.
Okay, so I think I can start answering, right? Great. So first question you guys asked, can we get that presentation slide? Yeah, I think I can share it with your moderators. So they can share it with you with some kind of a Google link or something like that. I will do that as soon as this ends. Now, the next question is, how does data quality and availability important in the success of industrial projects? Data quality and availability. Yes. So when we talk about industrial projects, we might not always get the best data quality or the best availability. Some projects we get, some European projects, they have this millions of data rows with different formats, and they are in different languages, and they are not in a best quality also. So it doesn't matter what data quality we get the data from, we need to create pipelines in order to make the data valuable to us. You can create pre-process pipeline, you can pre-process them to become better, you can just normalize the data. It is our responsibility as data scientists and machine learning engineers. It is you guys' responsibility to make the data quality by yourself and availability of the data. In some cases, we have a lot of data. Even if they are not in good quality, we have a lot of data. But in some rare case scenarios, there might be not a lot of data available. In that case, first of all, we are considering, do we have to go into a models that need a lot of data? For example, as I example to you guys, do we have to go into neural network model? Can we do it with a simple machine learning algorithm? If we can do it with less data, we will go into that machine learning algorithm. If not, we can use things like data augmentation. We can create data out of the data we already have. The term is data augmentation. I think you guys might be familiar with it. So with that, we can generate more data. And something came into like recent days, we are using generative AI to create data also. It have its downfalls and advantages and disadvantages, but we are using generative AI also to create data. So we have a lot of data available. The next question is, can we customize the Google News 300 word-to-vec model from Hugging Face for domain-specific problems like loss? Okay, word model from Hugging Face for domain-specific. I think you should be, but that depends on what is your use case exactly. Like word-to-vec is you're converting words to vectors. So the answer is yes, but with the complexity of your problem and the output that you looking for from your problem, this can change. So that's the answer I can give for that. Nowadays, AI is developing. So is it worth studying software engineering and etc.? Okay, this is a good question. I think a lot of people ask this. So I can't speak for everyone, but I can speak what I have in mind. So software engineering is not just coding. So I know a lot of guys say this. When you go into ChatGPT, you can just get a code. But when you come into software engineering industry, you realize, okay, software engineering is not just coding. You have a lot of thinkings to do. You have a lot of meetings to come into. You have a lot of clients to face in. So in that aspect, I don't think like all the software engineers will be jobless and they will be waiting at the phone. But there is this risk. For example, in 2010, if someone can just type code, that is a big skill. Not 2010, let's say 2005. If someone can just type code, that is a really big skill, right? They might get job really fast. But now writing code is not that much of a big skill. Like syntax, we have TensorFlow, we have ChatGPT, we have Gemini, everything. Just code writing is really easy. So in that sense, you might not get that. But if you improve more than that, if you start thinking logically, if you start learning different things, cloud computing, AI, cybersecurity, those kind of thinking things, as far as I think, AI can't replace, at least not still now. So if you're studying software engineering, don't just get demotivated. Just try to become unique. Try to create a talent out of it instead of just coding for the sake of coding. And don't worry about this. I know that a lot of companies coming in and showing demos, just some AI is doing software engineering projects from the starting to beginning, starting to end. Those demos are proven to be false. I know recently there is some big news that coming from a big company like that. So if you're doing software engineering now, don't get demotivated and don't stop doing software engineering, because we are still recruiting, some other companies is still recruiting, but just make sure you are having the talent inside you. Yeah. The next question, what are the challenges in implementing machine learning models for fraud detection in industries like banking and finance? The first challenge is getting the data. So when you work with banks and finance sectors, they really don't want you to get their data. Why? Those data is really sensitive. You can't just go in and look into someone's account and get all their data. So some of the finance sectors doesn't give the data you request, even though they want you to build a model. So in such case, that is one of the biggest challenges we face when we are working with finance. In such cases, you can build anonymization pipeline. So you can just mask their names, mask their IDs, the exact IDs, and take the raw data from the bank, which doesn't include any of the personal information. That is one of the biggest challenges. Other than that, banking sector fraud detection is bit sensitive also, because you have to decide in a very high accuracy. It should be at least 99, like really high accuracy. Otherwise, you might upset the customers that are doing legal transaction, which is not really good look for a bank or a finance institution. So the next challenge is building your model as accurate as possible. Those are the two biggest challenges comes into my mind at this time, but there can be other challenges also. Good. The next question is how we need to do data cleaning and pre-processing for event log data set, CSV, the column separate. Sorry, that question went away. Okay, we'll get to this question. Can you recommend good course or learning pathway to learn Azure? Okay. Azure have this, so Microsoft have this partnership program. They have this Microsoft Associate certificate and those kind of stuff, which is really good if you're looking for jobs also, because there is a job market if you have that certificate. Other than that, exact Azure course, I am not 100% sure. But if you search on Coursera or different YouTube channels, I think you might get some. But if you are really going forward for that site, try to do this Microsoft Azure certificates, which cost some amount of money, but it is really good when you come into job market. Okay. Some cloud providers have limitations like max image size. So should we bake the model into the image or make the container download model on starting? Okay. So should we break the model into the image or make the container download the model in the starting? That depends. So let's say there is an initial point, right? So we can push our model into things like Elastic Container Repository, ECR, and then we can download the model. So let's say the image is giving the more than max size, so they won't let us upload it into the ECR or pull the image into our instance. In this case, you can do what you told, like you can write a Docker image saying, okay, pull the model from this repo into the image and then start building. But that will take the building process will take bit of a time rather than the usual building of the Docker. So that disadvantage here is there. But what you mentioning here is a legit way. I think we can do it also. Yeah. The next thing is what is exactly called the data pipeline. Okay. Data pipeline can be different from one project to project. So in our projects, in data pipeline, these kind of things happen. We will get data from a stakeholder that comes to us to build some kind of a solution. This data is not in the format or not in the quality, as I explained earlier, as we want. We need to pre-process this data and we need to add missing values, the things we need to do, and then we need to make this data in good quality. Sometimes we might need to again anonymize the data because we can push this sensitive data into a pipeline. We have to process this data and then only push it into the model, our model, or the AI model that we are going to create. So in our projects, what we call data pipeline is this processing part and getting ready the information to push into the solution that we will be creating. Do you have any tips on building an AI that performs document analysis, especially considering that we may not have access to the large compute clusters? Okay, so these days, best way to do this is using large language models. So I think you guys might be familiar with large language models like GPT, which is ChatGPT, and we have Gemini, we have different kind of large language models. So there is something called document intelligence. So now large language model is trained on a billions of text scopes. So it already have this big amount of knowledge. But let's say we are asking for a specific document analysis. It might be related to law, as we had in the last question, or it might be related to something else. You can just take this document data and feed it to this large language model and retrain it, not retrain it, actually fine tune it in or to make it to answer the questions from this document or analyze the document and get the output from it. So if you don't have big compute clusters or anything, the best thing I can recommend is using large language models and document intelligence together and using less amount of compute resources. You should be able to do that. But keep in mind, you might have to pay for the large language model providers such as Facebook, Google, or Microsoft. Yeah. Some pre-trained models support customization or fine-tuning. How can we train a model in a way another user can fine-tune the model for themselves? Okay, this is a really good question. Pre-trained models support customization, fine-tunes, how can we train? So in here, actually, you have to build a big pipeline around the thing you need. For example, let's say we'll get a simple model. Let's say I have a model called ABC. This model have fine-tuning parameters like epochs or layers we can add. Then you have to go in there. It's really hard to explain. So you have to take the model you have, and Python, there is some way you are inputting these events into that model. For example, you might say, okay, abc.model epoch equals to 10. Adding layers equals to list of layers that you are going to add into on top of this ABC model. Now, this is the syntax you have. You can create the API to take this information from the user. How many epochs you need, what are the layers you need, this layers. Then you can create another class, another function, which will have those parameters, which is connected to the API. API will get all the details. And then that function will itself call this model.epochs is equal to the epochs that the user inputted. Layers is equal to the layers that user inputted. Those kind of things. And then you can start the training process as separate process in an instance or something like that. That's how you can create that kind of pipeline. I'm not sure I explained it really clearly, but these kind of things exist. So you can search, just search on the internet, because it's not a big thing and it's not mostly ML thing. It's algorithmic oriented and it's a thing you can do with Python itself. So yeah. Cool. Okay, again, the last question. So how we need to do the data cleaning and pre-processing for event log data set, comma separated values to XES or cleaned event log to conduct the process mining task. That buddy, actually, I can't give exact answer without looking at the data. So that actually, I think I have to look at the data and then pre-processing part, then only I can say how to clean what kind of things to clean. For example, event logs might in different encoding values because they are coming from servers. So we have to convert it, might have to convert it to bytes and take it like that. For this question, I might not be answered directly. Yeah. So the next question, in dataset with capital gain and loss, there are many zero values and outliers cannot be dropped, trimmed because the upper and lower bound is zero. What steps to follow? Zero is yeah. It's also, as far as my knowledge, drop those also. Upper and lower bound both is zero. Okay, so I think you can modify the data points that in here. Again, I'm not 100% sure about this question because I haven't seen the data sets also. So we have to find, as far as I can think of right now, we have to, you can even trim that. Okay. So the best thing you can do, as far as I see, if you can populate dataset with the data that outliers are not zero and give it like lengthy way to learn, like there are values, zero value target variables, also like there are other values like more than zero. If you can balance the data set with both zero and other different values, adding lot of data, I think that might fix the problem. But other than that, I need to look into the data set and then look what we can do with the use case and everything. So yeah, I might not be able to answer exactly for that question. Yes. Is it possible to have explanation about ARIMA and SARIMA models for time series? Yeah. There are different explainable AI models. So as far as I know, for ARIMA and SARIMA, there should be an explainable AI model. Like, so it's happening like this. There are different libraries that help you to integrate with these kind of models. And then you can see the explainability. Okay, why did this happen? Why does that happen? But again, I have to search on internet what exact those kind of libraries take on this explainable AI. Yeah, the next one is, can we use AutoGloon to automate ML stuff and how it works? AutoGloon, to be honest, I haven't used it. But to automate ML stuff, when you meet automate ML stuff, it can be two different things. One thing is automatically figuring out the parameters. For example, figuring out what kind of a learning rate to have, what kind of epochs to have while the code is running. Or automate ML stuff when you can also mean pre-processing the data and those kind of stuff. So I haven't used AutoGloon. I'm not much familiar with it. But automate ML stuff, pre-processing things, you can use Azure. Azure, there are a lot of functionality like data factory, those kind of things to pre-processing part. And for figuring out what, like automatically changing the epoch set learning rates and figuring out what is the best possible loss function, those kind of things. You can use different kind of AutoML models. You can just search for AutoML and the use case you exactly have. There should be multiple ways to do AutoML on that side. Yeah. Did you use chat with RTX? No, I didn't use it yet, but I heard it's really good because it's the first time they are incorporating large language model into a laptop we use rather than using a cloud computer or somewhere to host the large language model. As far as I know, it's NVIDIA's product. So I have really big hopes for it, but I haven't just tested it yet. Yes. Cool. It seems like that all the questions.
Thank you, sir. Now let's take a moment to express our gratitude to Mr. Pamoda Dilranga for sharing his expertise with us today. Sir, your insights are invaluable, and we thank you for your contribution to our workshop. As a token of appreciation, we have a small gesture of thanks for you.
Thank you for inviting me also.
As we draw towards the conclusion of our session, I'd like to express my deepest gratitude to Mr. Pamoda Dilranga and to all our participants. Your active participation and unwavering enthusiasm have made today's session truly exceptional. Let's march forward together, continuing to delve into the vast realm of AI and unlocking into boundless potential. Stay connected with us by following our social media platforms for more exciting opportunities that lie ahead. Thank you once again, and we look forward to seeing you in the future events. I wish you all a good evening.